In this video, we'll be talking about the mole, which is the SI unit of the amount of substance. Its symbol is written as mole. So its symbol is written as simply as MOL, mole. So it is the measure of how many elementary entities of a substance are that are present in an object. So these elementary entities can be anything. They can be not anything. They are related to the very small to the very small particles like atoms. So these elementary entities may be atom, a molecule, an ion, or any subatomic particle such as an electron. So the mole is number of elementary entities, and these entities can be atoms, molecules, ions, or electrons. So the reason why the mole was invented was because, as we know that the mole is mostly used in chemistry. So chemistry is all about the chemical reactions of different elements, different molecules. So these chemical elements happen that they take place at molecular and atomic levels, where using like grams is just inadequate. Using grams doesn't make any sense. So that's why the mole was created. So therefore the mole is was used in order to calculate very small yet very large entities. So in the video you will know how much a big of a number of a mole of elementary entities are in a mole. So first of all, the concept of using a mole is is the same as using the words like a pair or a dozen. So let me just write it down. How so? For example, um, I think use the blue color here. For example, changing the colors, a pair of gloves, and then we have another sentence like a dozen of eggs, and then we have finally a mole of atoms. So here I have highlighted these. I have changed the color, the words color of to orange to highlight it. So here, for example, this sentence, a pair of gloves. So we know a pair means two. So which means two gloves. And then we have for here a dozen of eggs. Here we have dozen, which means 12. That means 12 eggs. And then we have here mole. So the mole means the specific number of elemental entities. So how big of a number is, so how much of a number it is? It is 6.0221407 multiplied by 10 power 23 elemental entities, or in this case atoms. So this much number of atoms. A pair of gloves meaning two gloves, A dozen of eggs meaning 12 eggs. A mole of atoms meaning this amount of atoms. I was just about to say eggs, sorry. So, for example, let's say to consider an example, because mole is now defined in terms of this specific amount of elemental entities. So, to give you an example, for example, let's say, I think white will be better color here. For example, you have a beaker, two beakers. In one beaker, you have, say, I think this color will be alright. In one beaker, you have mercury, and in one beaker, you have bromine. So we're just gonna keep it to the to we're gonna keep it to these to the elements, to the atomic, into the elements of atoms. Single element of atom, here we have the mercury, and here we will have bromine. So let's say that this beaker contains 10 moles of mercury, and here we have 10 moles of bromine. So here this implies that 10 moles of mercury, 10 moles of bromine, which means that these both beakers contain the same amount of elemental entities, which in this case it has 10 moles of atoms of mercury, and here we have 10 moles of atoms of bromine. But they will have different volume, and in that case they will have different mass. They both will have different volume and have different mass. Different volume and mass, because because of the fact that they are different elements, and their atomic number and atomic mass are not the same. In case of mercury, you have atomic number of 80, and in 10 moles of bromine, the bromine atomic number is, I believe, 35. I guess both. The mercury atom has atomic number of 80. The bromine has atomic number of 35, if I believe I'm correct. So the mole is defined exactly as this number, 6.02214076 multiplied by 10's power 23 elemental entities. And this number is known as the Avogadro's number. The Avogadro's number. And this number was named after the Italian scientist Lorenzo Romano Amendio Carlo Avogadro. So the first picture is of him. So let me just write down his name, which is very long indeed. Lorenzo Romano Amendio Carlo Avogadro. Avogadro. So the Avogadro number was named after this Italian scientist. Avogadro was just gonna call him. So let's just remind you of how big of this number is. To comprehend how big of a number this is, let's say you have, I think I'm just gonna scroll down. Let's say, where will be, I think here will be better drawing. For example, you have a glass. Let's say this is a glass, and you have water in it, and this glass contains about 10 moles of water molecules. So this glass of water contains about 10 moles of water molecules. So these 10 moles of molecules are greater. They are greater than the grains of sand in Sahara Desert. So that's how big of this number is. That 10 moles of water molecules are greater in number than the grains of sand in the Sahara Desert. So that's how big of a number is. Why this big number? Because although it is big, this number can't be used in our daily lives. For example, let's say we have a pair of, for example, in case of eggs, let's say we say a mole of eggs. So this will be a very big quantity. So why use this huge number in mole? Because you know the chemical reaction taking place in atomic molecular level. So this number indeed is very large, but it is it is a good number. It is a good measure for for in measuring the chemical quantities, in which case we are dealing with atoms and molecules. So to give you another example, for example, if the atom was the size of a grapefruit, if for example atom was the size of grapefruit, then one mole will be approximately the same volume as Earth. So that's how big of a number is. To comprehend how this big of a number is, that's how big of a number is. So if atom, for example, were to about the size of a grapefruit, then one mole of atoms will be approximately the same volume as Earth. So where this word mole came from? So the name mole was introduced by the chemist Wilhelm Ostwald. So this is the picture of him. Let me write his name here. Wilhelm Ostwald. So in 1894 he named mole, which was from the German word, mole from German word, which was molecule, which was from the word molecule. I hope I pronounce it correctly. Molecule, which means basically molecule. And the word was derived from the Latin moles, from Latin moles, which means mass. So Wilhelm Ostwald was the person who coined the term mole. And to give you some history of it, so prior to 1959, and just gonna scroll down to get some space to write down. So prior to 1959 prior to 1959, both the organizations IUPAP and IUPAC, let me just write down and then I'll explain what these organizations mean. IUPAP, and we have IUPAC. So IUPAP means the International Union of Pure and Applied Physics, while the IUPAC means the same, but in the last, instead of using P here, they are using C, which means chemistry. So the International Union of Pure and Applied Chemistry. Above is, um, let's, I guess, just write down the name, full name, for the convenience. Will take some time. The International Union of Pure and Applied Physics. While in this case is the same here, instead of physics we have chemistry. So these both organizations before 1959, they both used oxygen to define the mole. Used so used oxygen to define mole. But each organization had a different method to define the mole. For example, in case of IUPAC, in case of IUPAC, the chemists were using the oxygen, which has mass 16 gram. The number of atoms of oxygen of mass 16 gram. Number of atoms of oxygen in mass 16 gram. While the while in IUPAP, the physicists were using the same thing, but instead of using oxygen, they were using the isotope of oxygen, which was oxygen 16 isotope. Where both methods were different, but instead of but the usage of elements was different, although they were using the same element, but one was using an isotope of element, and that was the IUPAP, the International Union of Pure and Applied Physics. So there was a conflict there, because they were using the same yet kind of different method to define the mole. So there was a conflict there. So in 1959 to 1960, where do I write? Here we have end of space here. So I'm just gonna write to the right side. In 1959, oh sorry, in 1959 to 1960, these both organizations agreed to define the mole as, uh, let's just use the green color here. So they defined the mole as, will take some time to write the definition. The mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon 12. 12, its symbol is MOL. So this was the definition. So this was the definition that these both organizations, the IUPAC and IUPAC, agreed on. The definition was the mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon 12. Its symbol is mole, MOL. So this definition was adopted by the CIPM, which is the International Committee for Weights and Measures, in 1967. So where do I write? I think I'm gonna write here. So in 1967, it was adopted by CIPM, which is the International Committee for Weights and Measures. They adopted it in 1967, and in 1971, it was adopted by the 14th CGPM. CGPM meaning the General Conference on Weights and Measures. And then in May 2019, in May 2019, the mole was again redefined in terms of Avogadro's number. So the new definition was not using was is the new definition is will again take some time so to write the definition, so please bear it with me. The mole symbol mole is the SI unit of amount of substance one mole contains. Exactly, not approximately, but exactly the number I told you in the start of the video, 6.022140076 multiplied by 10's power 23 elemental entities. This number, the number is the fixed numerical value of the Avogadro's constant, which is written by the symbol Na when expressed in the unit mole, and is called write it here, and is called the Avogadro number. So this is the whole definition, the current definition. Okay, then so what was the definition? The mole symbol mole, MOL, is the SI unit of amount of substance. One mole contains exactly 6.022140076 multiplied by 10's power 23 elemental entities. The number is the fixed numerical value of the Avogadro constant Na when expressed in the unit mole, and is called the Avogadro number. So what? So first of all, what was the reason? The question that occurs, that what was the reason to redefine it? What was the problem? You see, so when you look at this definition, the recent definition that I write here. So if you pay attention to the definition, you can actually notice that there is an imposter. An imposter in this definition. So the imposter is this, not this value, but the kilogram. So if you have guessed correctly, I hope you guessed it correctly, the imposter was the kilogram. Why? Because the mole was relying on another base unit, that was the kilogram. But the main problem, but that's not a big problem. The big problem was that, as I mentioned in the start of the video, the whole reason for the mole, for the invention of mole, was because of the fact that the chemical elements occur at molecular and atomic levels. So why do we use a gram for a gram as it doesn't make any sense? Instead, we should use a specific, a small, a very large number that can encapsulate the measurement of those chemical reactions that happen in molecular and atomic levels. So that's why the gram doesn't make any sense. So that is why, like all the six base units that I covered in the previous videos, were then in their now in their now modern definition, they are now linked to to the natural constants of the universe, like the speed of light, the Planck's constant. So here again, the mole, just like the previous six base units, the mole was also linked to another constant, which is known as the Avogadro constant, known as the Avogadro number. So what is the Avogadro number? It's the 6.02214076 multiplied by 10 power 23 elemental entities. And this is not approximately, this is the exact amount of elementary entities that make up one mole. So that is why there was a need to redefine the mole as in terms of a, a specific number. So it was tied to the Avogadro number. So I think that covers it all, I guess. Mm, to my knowledge, I think the topic has been covered up. So this is was the whole lecture, the whole video about the mole. So why it is used, and I hope you have found this video informative. And if you do, then please don't forget to like, share, and subscribe to my channel, as it really helps my channel to grow, to put it to the wider audience on YouTube. And one thing more, that if you have any questions related to this video, you can comment down on this video and I'll try to answer it for you. So again, thank you very much for watching this video, and I'll see you guys in the next video. Thank you.